Malware. Malware is any software intentionally designed to cause disruption to a computer, server, client, or computer network, leak private information, gain unauthorized access to information or systems, deprive users access to information, or which unknowingly interferes with the user's computer security and privacy. History of malware. The early years, malware was primitive, often spreading entirely offline via floppy disk carried from computer to computer by human hands. As networking and the internet matured, malware authors were quick to adapt their malicious code and take advantage of the new communication medium. In 1971, Creeper, an experiment designed to test how a program might move between computers. In 1974, Wabbit, a self-replicating program that made multiple copies of itself on a computer until it bogs down the systems to such an extent that system performance is reduced and eventually crashes. Researchers named this virus Wabbit or Rabbit because of the speed at which it was able to replicate. In 1982, Elk Cloner, written by a 15-year-old, Elk Cloner is one of the earliest widespread self-replicating viruses to affect personal computers. Elk Cloner displayed a friendly little poem in the infected system. In 1986, Brainboot 6 sector virus, generally regarded as the first virus to infect MS-DOS computers, its origin stems from two brothers in Pakistan who created it to test loopholes in their company's software. In 1986, PC Right Trojan malware authors disguised one of the earliest Trojans as a popular shareware program called PC Writer. Once on a system, it would erase all of a user's files. In 1988, Morris Worm. This Morris worm infected a substantial percentage of computers connected to ARPANET, the forerunners of the Internet, essentially bringing the network to its knees within 24 hours. Its release marked a new dawn for malicious software. The author, Robert Morris, became the first malware author convicted for his crimes. In 1991, Michelangelo virus. It was so named because the virus was designed to erase information from hard drives. On March 6, the birthday of the famed Renaissance artist, the virus was at the center of a wild media storm with panic reporters claiming that it had infected millions of computers and that the world would see dark consequences on March 6. In reality, the virus only impacted about 10,000 systems, but the hype significantly raised public awareness of computer virus. In 1999, Melissa virus, generally acknowledged as the first mass emailed virus, Melissa utilized Outlook address books from infected machines and mailed itself to 50 people at a time. Types of malware. Ransomware. Ransomware is software that uses encryption to disable a target's access to its data until a ransom is paid. The victim organization is rendered partially or totally unable to operate until it pays, but there is no guarantee that payment will result in the necessary description key or that the description key provided will function properly. Number 2. File malware. Malware does not install anything initially. Instead, it makes changes to files that are native to the operating system, such as PowerShell or WMI, because the operating system recognizes the edited files as legitimate. A fileless attack is not caught by antivirus software, and because these attacks are stealthy, they are up to 10 times more successful than traditional malware attacks. Spyware. Spyware collects information about users' activities without their knowledge or consent. This can include passwords, pins, payment information, and unstructured messages. The use of spyware is not limited to the desktop browser. It can also operate in a critical app or on a mobile phone. Adware. Adware tracks users' surfing activity to determine which ads to serve them. Although adware is similar to spyware, it does not install any software on a user's computer or does it capture keystrokes. Trojan. Trojan distinguishes itself as desirable code of or software. Once downloaded by unsuspecting users, the Trojan can take control of victims' systems for malicious purposes. Trojans may hide in games, apps, or even software patches, or they may be embedded in attachments included in phishing emails. Worms. Worms target vulnerabilities in operating systems to install themselves into network. They may gain access in several ways through backdoors built into software, through unintentional software vulnerabilities, or through drive flash drives. Once in place, worms can be used by malicious actors to launch DDoS attacks, steal sensitive data, or conduct ransomware attacks. Virus. Virus is a piece of code that inserts itself into an application and executes when the app is run. Once inside a network, a virus may be used to steal sensitive data, launch DDoS attacks, or conduct ransomware attacks. Rootkits. A rootkit is software that gives malicious actors remote control of a victim's computer with full administrative privilege. Rootkits can be injected into applications, kernels, hypervisors, or firmware. They spread through phishing, malicious attachments, malicious downloads, and compromise shared drives. Rootkits can also be used to conceal other malware such as keylogger. Keyloggers. Keylogger is a type of spyware that monitors users' activity. Keyloggers have legitimate uses. Business can use them to monitor employee activity, and families may use them to keep track of children's online behaviors. Bots or botnets. A bot is a software application that performs automate tasks on command. They're used for legitimate purposes, such as indexing search engines, but when used for malicious purposes, they take the form of self-propagating malware that can connect back to a central server. Mobile malware. Mobile malware attack targeting mobile devices have risen 50% since last year. Mobile malware threats are as various as those targeting desktops and include Trojans, ransomware, advertising, click fraud, and more. They are distributed through phishing and malicious downloads and are a particular problem for jailbroken phones, which tend to lack the default protections that were part of those devices' original operating system. What is virus? A virus is submicroscopic infectious agent that replicates only inside the living cells of an organism. Viruses infect all life forms from animals and plants to microorganisms including bacteria and archaea. Different types of computer viruses. Number 1. Boot sector virus. This type of virus can take control when you start or boot your computer. One way it can spread is by plugging an infected USB drive into your computer. Web, web scripting virus. This type of virus exploits the code of web browser and web page. If you access such a web page, the virus can infect your computer. Browser hijacker. This type of virus hijacks certain web browser functions, and you may be automatically directed to an unintended website. Resident virus. This is a general term for any virus that inserts itself in a computer system's memory. A resident virus can execute anytime when an operating system loads. Direct action virus. This type of virus comes into action when you execute a file containing a virus, otherwise it remains dormant. Polymorphic virus. A polymorphic virus changes its code each time an infected file is executed. It does this to evade antivirus programs. File infectors virus. This common virus inserts malicious code into executable files used to perform certain functions or operations on a system. Multipartite virus. This kind of virus infects and spreads in multiple ways. It can infect both program files and system sectors. Microvirus. Microviruses are written in the same macro language used for software application. Such viruses spread when you open an infected document, often through email attachment. What is a network? A network consists of two or more computers that are linked in order to share resources such as printer and CDs, exchange file, or allow electronic communication. The computers on a network may be linked through cables, telephone lines, radio waves, satellites, or infrared light beams. Types of computer network. Local area network. A local area network connects computers over a relatively short distance, allowing them to share data, files, and resources. For example, a LAN may connect all the computers in an office building, school, or hospital. Typically, LANs are privately owned and managed. Wireless local area network. A wireless local area network is just like a LAN, but connection between devices on the network are made wirelessly. Wide area network, as the name implies, a wide area network connects computers over a wide area, such as from region to region or even continent to continent. The internet is the largest one, connecting billions of computers worldwide. You will you will typically see collective or distributed ownership models for WAN management. Metropolitan area network. Metropolitan area networks are typically larger than LANs but smaller than ones. Cities and government entities typically own and manage them. Personal area network. A server's one person, for example, if you have an iPhone and a Mac, it's very likely you've set up an app that shares and syncs content, text messages, emails, photos, and more across both devices. Storage area network a, is a specialized network that provides access to block level storage. Shared network or cloud storage that to the users looks and work like a storage drive that's physically attached to a computer. Campus area network is also known as corporate area network. A CAN is larger than ALN but smaller than WAN. CAN serve sites such as colleges, universities, and business computers. Virtual private network is a secure point-to-point connection between two network endpoints. Establishes an encrypted channel that keeps a user's identity and access credentials as well as any data transferred invisible to hackers. Purpose of network. A computer network is a set of computers sharing resources located on or provided by network nodes. The computers use common communication protocols over digital interconnections to communicate with each other. These interconnections are made up of telecommunication network technologies based on physically wired optical and wireless radio frequency methods that may be arranged in a variety of network topologies. Disadvantage: purchasing the network cabling and file server can be expensive. Managing a large network is complicated, requires training, and a network manager usually needs to be employed. If the file server breaks down, the file on the file server became inusable. Email might still work if it is on separate server. The computer can still be used but are isolated. Viruses can spread to other computers throughout a computer network. There is danger of hacking, particularly with wide area networks. Security procedures are needed to prevent such abuse. A firewall. Types of network devices. Types of network devices. Here the common network devices list. Hub. Hubs connect multiple computers networking devices together. A hub also acts as a repeater in that it amplifies signals that deteriorate after traveling long distances over connecting cables. A hub is the simplest in the family of network connecting devices because it connects LAN components with identical protocols. Switch. Switch generally have a more intelligent role than hubs. A switch is multi-port device that improves network efficiency. The switch maintains limited routing information about nodes in the internal network, and it allows connection to systems like hubs or routers. Its transfer of ALNS are usually connected using switches. Router. Routers help transmit packets to their destinations by charting a path through the sea of interconnected networking devices using different network topologies. Routers are intelligent devices and they store information about the network they're connected to. Most routers can be configured to operate as packet filtering firewalls and use access control lists. Bridge. Bridge are used to connect two or more host or network segments together. The basic role of bridge in network architecture is storing and forwarding frames between the different segments that the bridge connect. Gateway. Gateway normally work at the transport and session layers of the OSI model at the transport layer and above. There are numerous protocols and standards from different vendors. Gateways are used to deal with them. Gateway provide translation between networking technologies such as open system interconnections, and transmission control protocol or internet protocol. Modem. Demodulators are used to transmit digital signals over analog telephone lines. Thus, digital signals are converted by the modem into analog signals of different frequencies and transmitted to a modem at the receiving location. Repeater. A repeater is an electronic device that amplifies the signals it receives. You can think of repeater as a device which receives a signal and retransmits it at a higher level or higher power so that the signal can over longer distances, more than 100 meters for standard LAN cables. Repeaters work on the physical layer. Access point. While an access point can technically involve either a wire or wireless connection, it commonly means a wireless device. An AP works at the second OSI layer, the data link layer, and it can operate either as a bridge connecting a standard wired network to wireless devices or as a router passing data transmission from one access point to another. Concept of Internet technologies. The Internet is a global network of billions of computers and other electronic devices. With the Internet, it's possible to access almost any information, communicate with anyone else in the world, and do much more. You can do all of this by connecting a computer to the Internet, which is also called going online. World Wide Web, also called Web or WW, it is collection of information, resources, pictures, sounds, multimedia on the Internet that are linked and connected together using a software product such as Netscape makes accessing and linking to web pages containing information easy. The World Wide Web was invented by Tim Berners-Lee in the CERN laboratory in March 1989. Basic Internet Principles. TCP or IP, the Internet is the network that connects computers all over the world. It works according a set of agreed upon protocols. TCP or Transmission Control Protocols and IP or Internet Protocol are the most commonly used protocols for using the Internet. But there are others at the lower levels. The combination is simply known as TCP or IP. UDP. Most applications use TCP. However, an example of a situation in which it is desirable to use a lower level protocol is the case of audio streaming. If you want to download a sound file, it can take some time even though it may be compressed. You have to wait perhaps some considered time, relatively speaking, for the complete file to download before it can be played. An alternative is to listen to the sound as it is being downloaded, which is called streaming. One of the most popular technologies is called real audio. Domain names. A domain name is the user-friendly equivalent of an IP address. It is used because the number in an IP address are hard to remember and use. It is also known as the host name, the domain name system. A program, say a web browser, that wants to use a domain address usually needs to convert it into an IP address before making contact with the server. The domain name system provides a mapping between IP address and domain names. All this information cannot be located in one place, so it is held in a distributed database. Port numbers. To identify a host machine, an IP address or domain, an IP address or a domain name is needed to identify a particular server on a host. A port number is used. A port is like a logical connection to a machine. Socket is the software mechanism for one program to connect to another. A pair of programs open a socket connection between themselves. This then acts like a telephone connection. They can converse in both directions for as long as the connection is open. In fact, data can flow in both directions at the same time. Downloading and uploading files from internet. The terms downloading and uploading are generally used while browsing the internet. Receiving data or a file from the internet on your computer is referred to as downloading. Uploading refers to the process of sending data or a file from your computer to a remote location on the internet. Downloading files from web. The process of copying a file, such as a game or utility, from one computer to another through the internet is known as downloading. The transmission of a file from a server or remote computer system to a user's PC is known as downloading. Downloading a file from the perspective of an internet user is making a request for a file from a server computer and receiving it. Computer organization and architecture is the study. Computer organization and architecture is the study of internal working, structuring, and implementation of a computer system. Architecture in the computer system, same as anywhere else, refers to the externally visual attributes of the system. Externally visual attributes here in computer science mean the way a system is visible to the logic of programs, not the human eyes. Organization of a computer system is the way of practical implementation that results in the realization of architectural specification of a computer system. Architecture of a computer system can be considered as a catalog of tools available for any operator using the system. One organization will be way the system is structured so that all those catalog tools can be used efficiently. Detailed definition of basic units of measurement of computer. Measurement of computer. Number 1. Bit. Bit is the smallest unit of computer memory that can store either the status of yes or no. Byte. Byte is equivalent to 80 bit. 1 byte can represent 256 states of information such as numbers of numbers associated with text. 1 byte can also represent 1 characters. 10 bytes can be equivalent to 1 word. 100 bytes can be equivalent to a medium-length sentence. Kilobyte. 1 kilobyte is approximately 1,000 bytes, but 1 kilobyte definition is equivalent to 1,024 bytes. 1 kilobyte is equivalent to a short paragraph. 100 kilobytes is equivalent to 1 page A4. Megabyte. 1 megabyte is approximately 1,000 kilobytes. When a new computer was born, 1 megabyte was considered a high amount of data. It is normal for a computer to have a 500 gigabytes hard drive, which is normal for a megabyte. Gigabyte. 1 gigabyte is approximately 1,000 megabytes. 1 gigabyte is a fairly common term used today when referring to this space of storage drive. 1 gigabyte is a large amount of data that is nearly twice the amount of data that a CD-ROM can store. Terabyte. 1 terabyte is approximately 1 trillion bytes or 1,000 gigabytes. This unit is so large that is not a universal term yet. 1 terabyte can store about 3.6 million photos of 300 kilobytes size or encyclopedia. 10 terabytes can store a library that is a large amount of data. Petabyte. 1 petabyte is approximately 1,000 terabytes or 1 million gigabytes. It is difficult for you to imagine the amount of data that a petabyte can store. 1 petabyte can store about 20 million four-door filing cabinets filled with text. It can store 500 billion pages of standard-size printed text. With this amount of data, we'll need about 500 million floppy disks to store. Exabyte. 1 exabyte is approximately 1,000 petabytes. In other words, 1 petabyte is approximately 10 cups, 18 bytes, or 1 billion gigabytes. It is very difficult to compare with an exabyte. One compares 5 exabytes that contain an equal amount of all the worlds of all humanity. Zettabyte. Zettabyte is approximately 1,000 exabytes. Nothing compares to a zettabyte, but to represent it will need to use a lot of is and OS. Yottabyte. A yottabyte is approximately 1,000 zettabytes. Nothing is comparable to a yottabyte. Brontobyte. Brontobyte is approximately 1,000 zottabytes. The only thing that can be said about the size of a brontobyte is that there are 27 digits behind the one digit. Von Neumann model. Von Neumann proposed his computer architecture design in 1945, which was later known as von Neumann architecture. It consisted or a control unit's arithmetic and logical memory unit, registers and inputs or outputs. Von Neumann architecture is based on the stored program computer concept where instruction data and program data are stored in the same memory. Components of von Neumann model. Central processing unit, the part of the computer that performs the bulk of data processing operations, is called the central processing unit. It refers to as the CPU. The central processing unit can also be defined as an electric circuit responsible for executing the instructions of a computer program. Control unit. The control unit of a computer system controls the operation of components like ALU, memory, and input or output devices. The control unit consists of a program counter that contains the address of the instruction to be fetched and an instruction register into which instructions are fetched from memory for execution. Arithmetic and logic unit. The arithmetic and logic unit performs the required micro operations for executing the instructions. In simple words, ALU allows arithmetic, add, subtract, etc., and logic and or not, etc. operations to be carried out. Registers. Registers refers to the high-speed storage areas in the CPU. The data processed by CPU are fetched from the registers. Buses are the means by which information is shared between the registers in a multiple register configuration system. A bus structure consists of a set of common lines, one for each bit of a register, through which binary information is transferred one at a time. Control signal determine which register is selected by the bus during each particular register transfer. Advantage. Sharing devices such as printers save money. Site software licenses are likely to be cheaper than buying several standalone licenses. Files can easily to be shared between users. Network users can communicate by email and instant messenger. Security is good. Users cannot see the user's file unlike on standalone machines. Data is easy to back up as all the data is stored on the file server. Data representation in computer organization. Data. Data can be anything like a number, a name, notes in a musical composition, or the color in a photograph. Data representation can be referred to as the form in which we store the data, process it, and transmitted it. In order to store the data in digital format, we can use any device like computers, smartphones, and iPads. Electronic cir- circuitry is used to handle the stored data. Digitization. Digitization is a type of process in which we convert information like photos, music, numbers, text into digital data. Electronic devices are used to manipulate these types of data. The digital revolution has evolved with the help of four phases, starting with the big, expensive standalone computers and progressing to today's digital world. Numeric data is used to contain numbers, which helps us to perform arithmetic. Binary digits or bits are used to show the digital data, which is represented by 0 and 1. The binary digits can be called the smallest units of information in a computer. The main use of binary digit is that it can store the information or data in the form of zeros and ones. Numeric data is used to contain numbers, which helps us to perform arithmetic operations. The digital devices use a binary number system so that they can represent numeric data. The binary number system can also be represented by two digits, 0 and 1. Character data. Using the character data, we can form our address, hair color, name, etc. Character data normally takes the data in the form of text. With the help of the text, we can describe many things like our father name, mother name, etc. Digital devices to represent character data including Unicode, ASCII, and other types of variants. The full form of ASCII is American Standard Code for Information Interchange. It is a type of character encoding standard which is used for electronic communication. Unicode is also known as the Universal Character Encoding Standard. Unicode provides a way through which an individual character can be represented in the form of web page, text files, and other documents. ASCII code provides code for 128 characters, while Unicode provides code for roughly 65,000 characters with the help of 16 bits. In order to represent each character, ASCII code only uses 1 bit, while Unicode supports up to 4 bytes.